In the realm of infectious diseases, a new viral threat has emerged, capturing the attention of health officials and scientists worldwide. This stealthy pathogen, known as human metapneumovirus, HMPV, has recently surged in China, sparking concerns about its potential impact on global health. HMPV is a respiratory virus similar to the common cold or the flu, but with its own unique characteristics and challenges. First identified in 2001, HMPV has been silently circulating among humans for decades, often mistaken for other respiratory illnesses. HMPV is a single-stranded RNA virus, meaning its genetic material is composed of RNA, a molecule similar to DNA. This virus primarily targets the respiratory system, infecting the cells lining the nose, throat, and lungs. While HMPV can infect individuals of all ages, young children, the elderly, and those with weakened immune systems are particularly vulnerable to severe complications. Understanding the nature of HMPV, its mode of transmission, and its potential consequences is crucial for developing effective preventive measures and treatment strategies. The recent surge in HMPV cases in China has raised alarms, prompting researchers and health authorities to intensify their efforts to study and control the virus. The outbreak, which began in late 2024, has primarily affected young children, overwhelming hospitals and pediatric wards in major cities like Beijing. The rapid spread of HMPV in China serves as a stark reminder of the interconnectedness of global health and the importance of early detection and response to emerging infectious diseases. As the world grapples with the ongoing COVID-19 pandemic, the emergence of HMPV underscores the need for continued vigilance and investment in public health infrastructure. Human metapneumovirus spreads through respiratory droplets, tiny particles expelled from the nose and mouth of an infected person when they cough, sneeze, or even talk. These droplets can travel up to 6 feet, potentially infecting anyone within their path. HMPV can also spread through direct contact with infected secretions, such as saliva or mucus, or by touching contaminated surfaces. Once the virus enters the body, it invades the cells lining the respiratory tract, replicating and triggering an immune response. The symptoms of HMPV infection are often similar to those of other respiratory illnesses, making it difficult to distinguish from the common cold, the flu, or even COVID-19. Common symptoms include cough, fever, runny nose, sore throat, and shortness of breath. In some cases, HMPV can cause more severe respiratory problems such as bronchiolitis, an inflammation of the small airways in the lungs, or pneumonia, an infection of the lungs. Infants, young children, and older adults are at higher risk of developing serious complications from HMPV. Compared to other respiratory viruses, HMPV shares similarities with both influenza and respiratory syncytial virus, RSV. Like influenza, HMPV is a single-stranded RNA virus that causes seasonal outbreaks, primarily during the winter months. However, unlike influenza, there is currently no vaccine available to prevent HMPV infection. HMPV also shares similarities with RSV, another common respiratory virus that primarily affects young children. Both viruses can cause bronchiolitis and a pneumonia, and both are spread through respiratory droplets. However, HMPV is a distinct virus with its own unique genetic makeup and clinical presentation. Human metapneumovirus was first discovered in 2001 by Dutch researchers who were studying a group of children with respiratory illnesses. Using advanced molecular techniques, they identified a previously unknown virus, which they named human metapneumovirus due to its similarities to both human and avian metapneumoviruses. Further studies revealed that HMPV had been circulating among humans for decades, often misdiagnosed as other respiratory infections. The detection of HMPV requires specialized laboratory testing, as its symptoms are often indistinguishable from other respiratory illnesses. Polymerase chain reaction, PCR testing, a highly sensitive molecular technique, is commonly used to detect the virus's genetic material in respiratory samples. However, HMPV testing is not routinely performed in many clinical settings, which may contribute to underreporting of cases. The recent surge in HMPV cases in China and other parts of the world has highlighted the need for increased surveillance and testing to better understand the virus's epidemiology and burden of disease. The reasons for the recent resurgence of HMPV are not fully understood, but several factors may be contributing to the increase in cases. One possibility is that the relaxation of COVID-19 mitigation measures such as mask wearing and social distancing has led to an increase in the transmission of respiratory viruses, including HMPV. Another possibility is that the virus has undergone genetic changes that make it more transmissible or virulent. Further research is needed to determine the underlying causes of the recent HMPV outbreak and to inform public health interventions. As human metapneumovirus continues to spread, understanding prevention and treatment options is paramount. Currently, there is no specific antiviral medication available to treat HMPV infection. Treatment focuses on relieving symptoms and supporting the body's natural immune response. Over-the-counter pain relievers and fever reducers can help alleviate discomfort, while adequate hydration is essential for thinning mucus and preventing dehydration. In severe cases, hospitalization may be necessary to provide respiratory support, such as oxygen therapy or mechanical ventilation. The absence of a vaccine against HMPV underscores the importance of preventive measures in curbing its spread. Frequent hand washing with soap and water for at least 20 seconds remains one of the most effective ways to prevent the spread of respiratory viruses. If soap and water are not readily available, alcohol-based hand sanitizers containing at least 60% alcohol can be used. Covering coughs and sneezes with a tissue or the crook of the elbow rather than the hands can help prevent the spread of respiratory droplets. Avoiding close contact with sick individuals and staying home when feeling unwell can also limit the virus's transmission. The recent surge in HMPV cases serves as a stark reminder of the interconnectedness of global health and the importance of international collaboration in addressing emerging infectious disease threats. Sharing information, resources, and expertise across borders is crucial for developing effective surveillance systems, diagnostic tools, and treatment strategies. Investment in research to develop a vaccine against HMPV is also critical for protecting vulnerable populations and preventing future outbreaks. Raising awareness among healthcare providers and the public about HMPV, its symptoms and prevention strategies is essential for promoting early detection and reducing the burden of disease.